Now this video looks at when the secant meeting the circle at A and B and a tangent meeting at T are drawn to a circle from an external point P, the square of the length of the tangent equals the product of the lengths to the circle on the secant. So PA times PB equals PT squared. Now you also need to do the converse, but I'm not going through that in this video. So when you look at the diagram that I have there, we are going to look at two triangles. We're going to look at triangle PAT and we're going to look at triangle PTB. Okay, so consider triangles PAT and PTB. Now the reason for this, whenever I say something talking about the one side times by the other, so for our intersecting chords proof, for example, you should be thinking similar triangles, because similar triangles say the sides are in the same ratio. So you have to somehow be dealing with similar triangles. So we're going to consider these two triangles because that will deal with our PA, our PB, and also our PT squared, because our PT is common to both of those triangles. So you can see this PT is a common side. PA belongs to the small yellow triangle and PB belongs to the big triangle. Okay, so that's where we're going. That's our direction. Okay, now let's get started. We know that this angle P is common to both triangles. So angle TPA is common. All right. We also know that this angle here has to end up equaling this angle here because of the alternate segment theorem. So angle PTA has to equal angle TBA, and our code for the alternate segment theorem is that's upside down, but anyway, alternate segment theorem. I think I would just write it in full rather than using the code. So therefore, our third angle of each triangle has to be the same. So therefore, angle BTP has to equal angle PAT because of angle sum of a triangle. Therefore, triangle PAT has to be similar to triangle PTB, and the reason is it's got three equal angles. So now we can look at those ratios. Our ratios of sides, PA, or our corresponding sides, PA over PT, has to end up equaling PT over PB because of corresponding sides of similar triangles. So rearranging that, we have PA times PB has to equal PT squared. And that is our proof done. The code, this one's a bit weird. You have the tangent and going within.